camera is moving, so I think we're good. Yeah, so we can start. Who has the first question?
So a question about Elixir 2.0, when and why?
Yeah, so no, it's a good question. So I have this vision, like, okay, I'm going to give a long answer. Okay, so one of the, okay, short answer first. I'm trying to make my mind. So there is no plans for 2.0 at the moment, and in my mind, if we are going to have a 2.0, it should basically be Elixir, the last version of Elixir 1.0, so let's say like 1.85, but without all the features that we deprecated. So in my ideal world, when we have an Elixir 2.0, if you run Elixir, if you run your code on Elixir 1.85 or whatever it's going to be, and you don't have any deprecation warning, then you can run in 2.0 and nothing is going to break. That's my ideal world. And there are a couple reasons for this. Like, all right, okay, we can all dream, right? Like, what are now the long answer? What are the evidences that we have that this can actually be concrete and evidences against that? So for me, is that like Elixir was designed like to kind of be like a small language that is extensible, that you can take to different domains like machine learning, video processing that we're seeing. So the language is, a lot of the language is written in Elixir itself and is meant to be like extensible and malleable. So that has so far translated to the fact that, hey, if there is something in Elixir that we feel we need to change that requires Elixir 2.0, right, we can do it now because the language allows to extend and to change and so on. That's basically what we have done. Like, you know, when there is a new approach, we introduce the new approach, and with time we deprecate the old one, and hopefully, you know, and we keep on like growing the language, and hopefully we'll be able to do that and not have something that pushes us to release a 2.0. So that's the general idea. The evidence against that is that, which is a small evidence. So in the 10 years, is it? Wait, 11 years of the language, we only have one issue in the issues tracker that would be a backwards incompatible change. So that's a pretty good record, right? Like in 11 years, there is one. And it's like super minor. It's like the issue is, so we have module attributes in Elixir, right? And then when you do @doc, you can add the documentation for that attribute. So the only thing we'll do is that we'll change, if you do like module get attribute of the doc attribute for something, it's going to be a different result. But that's it. Like, how many people are relying on that? It's like, it's a very, very small change. So hopefully 2.0, really long time for now. It's just when we're like, oh, all this craft, all these deprecation things that we have carried throughout the years, we want to get rid of them. Then we do it, but definitely not in a hurry. So I'm not expecting it anytime soon.
Okay, thanks. Who would like to ask the next question? Paulina, can you pass the microphone there?
So my question is related to Erlang and Elixir performance. Don't you think that data immutability and message passing made the whole language a little bit slow and limit the number of use cases where Elixir can be successfully used? In particular, have you ever encountered a situation where you had to say that Elixir is too slow to implement some problem and you have to pick another language?
All right, so do I think, all right, there are a couple of questions in there. I'm going to tell one, which is, and do I think that's a concern? I'll start with that, and no. And the evidence I can give is that we are running video pipelines in Elixir. We are running large machine learning models in Elixir. So we do have an escape hatch, which is pretty much, because we can say like, oh, okay, we have a escape hatch, which is pretty much, well, when you really need performance, you can always go down to native code, right? And you can write C, and then you're going to get the performance. Which, by the way, even if you look at other languages, other high-level languages like Python and JavaScript, they do the same thing, right? And they are mutable, but they still do the same thing. They still fall back to C or something native when they need the performance. So the point I'm trying to make is that, sure, there is a price with being mutable. There is a price with message passing, but even languages, but there's also a price of just being a higher level language in general. And other high-level languages, regardless if they are mutable or immutable, they are all reaching out to the same solution, which is, okay, let's have some native code. So that's why, generally speaking, that's like I'm not concerned about this topic. I would put us in the same kind of like we are in a similar position as everybody. But then there's the question then, like, okay, so is this immutability deal and the message passing deal, like how much does it matter? Right, and for me, like there are many ways that we can look at immutability. But for me, software that is immutable, or let's say software that reduces mutability, it's easier to understand, right? Because now I do not have an object that I am passing to a method and that mutates the object in an implicit way that I don't know about it. Joe Armstrong, one of the creators of Erlang, he has a really good quote about object orientation. He says, like, in object orientation, you think you're getting a banana, but you are getting a banana and then the gorilla attached to it and then the whole jungle. Exactly because, you pass an object and changing that object or even calling a method on it can have an impact everywhere in the system, right? So we can also approach the question this other way, like, oh, immutability for me, or like avoiding side effects in general, it like makes me write better software and software that is easier to maintain. And a lot of people, they're going to put that on a higher priority than performance, because when you need performance, you can fall back, right? There is another anecdote that we can give, which is, so one of the inspirations that we got for starting this whole machine learning thing in Elixir, it's a project called JAX from Python. Is anybody familiar with JAX? Is anybody like with machine learning? Okay. Right, and it's very, and then it was like very, like I love the project. The project is very interesting. It's a project from Google, and it was like an inspiration, and it was an inspiration for us. And then we were reading the JAX docs. They were like, it's a Python library, right? And they were like, well, when you are working with JAX, you should treat all JAX data structures as immutable. And then I'm like, right? I know a language where kind of everything, you don't have to treat it. I know a language where things are actually immutable, right? And then later on, there was a quote like, well, in JAX, you should write your code in a functional style. And then I'm like, oh, I know a language where you can write your code in a functional style. And the reason why is because what they are doing is that when you're using this library in Python, what you do is that you say like, look, I want to multiply those two matrices. It's not like multiplying those things at the time, like when you call it, it's actually building a representation of a program that is going to compile to run on the GPU later on. And then they figure out that if you want to build something like that, immutability and functional programming, it's actually a better abstraction. Right, so, but yeah, no, but to answer the question, yes, there are also cases where we're like, oh, like if things were mutable, I would squeeze more performance from this, for sure. And then I either figure something out that I can squeeze that extra thing, right? So there are cases where I would say, okay, immutability would have helped. But generally speaking, for me, it's like the trade-offs are way more in favor of, immutability and message passing. Like those are the things that I want first, and mutability and the performance, they come second. I hope that makes sense. Cool, thank you.
One more?
I'm going to stay here.
So, because you mentioned Elixir Nx, so I'm curious how much of the code is written in Elixir itself, and is it like everything is written in Elixir, or you had to use some already implemented stuff in C or C++?
Yeah, so the way NX works is very similar to Jax, again, an inspiration. So what we do is that when you're using NX, we have this thing called defn, which is like the Elixir function definitions with a n at the end. And it stands for numerical definition. And the code that is in there, we are going to, when you call that function, we are going to execute the code that is in there, and we are going to build a representation of this code that is in there, and we are going to give it to a compiler that is written in C, actually C++. And it's the same compiler that TensorFlow from Google uses, and it's the same compiler that TensorFlow Python library uses. So there is, so that's the process. There is a library that is doing like all the compilation to CUDA or to ROCm, or even you don't need to have a GPU. You can like optimize the CPU. So that we treat like as a black box, really, even to the point where you can change that black box if you want, and then have a different kind of compiler. So yeah, so there is, so to sum it up, like you write some Elixir code. When you run that code, we build a representation of all like the numerical operations you want to do. We get this operation, we send to a compiler that is written in C, C++, and that compiler is going to give us a code that we call, and that's native code, or GPU code, and then we call it, and it's going to do things super, super fast.
Here's another one.
Okay, I got a question from the chat from our stream on YouTube, from Wojciech Orzechowski. What is the most challenging thing you would like to implement in Elixir, or libraries you contribute to?
Yeah, I think staying on the same topic, the whole machine learning thing is probably, I'm not sure if it would be the most challenging, but definitely for the last years has been the challenging one, because it's a huge domain, and it's also a domain that is like, it's in flux all the time. As we know, like every week there is something new happening, and then you have to process those news both from like, well, what is happening with my life perspective, but also it's like from like, oh, what is the technology behind it perspective, and I think there are a bunch of like exciting challenges just in general. I like to say like, I still like, it's still for me like hard to believe that we have like a subset of Elixir that runs on the GPU. It's something that if you told me like 10 years ago, I would be like, nah, that's a lie. That won't happen. So yeah, I would stick with that answer. But in 5 years ago, it would have been something different, and maybe 5 years from now, it's going to be something else as well. So.
Okay, so taking advantage that I sat here, I'll have a question. I would like to jump back those like 11 years. Like I was wondering, what were your thoughts? Like, how come you came up with the idea of bringing to life a new programming language?
Yeah, so actually, it's something that many of you may relate with. It was very cold outside, and I didn't want to leave the house. I'm kidding, but partially not. Elixir, like the first commits, they were in the middle of winter. It was like the beginning of January, and and for me, like I was already living in Poland, and I tried to avoid leaving the house. But the serious story, it's more something like I was working mostly with Ruby at the time, and at the time we were already hearing a lot about concurrency, and I was facing issues with trying to write concurrent software or debugging concurrency issues in Ruby. And then everybody was saying like concurrency is the future and so on. And I was like, well, if this concurrency thing is going to be the future, like maybe there are better ways of solving those problems that I'm facing right now. Like maybe there is some other language that are doing things better. And I like to say, like that future somewhat became true because like you have a wristwatch that has 4 cores, right? So the whole story is like, people are saying that the way we write software has to be different. We have to write software that is going to become where concurrency is is one of the main concerns of the software. And then I was like, okay, if that's happening, I should prepare myself. I started looking around, and I say there are like 2 points of no return for me. Like it changed the way I would think about software. The first one was when I found functional programming. And one of the reasons we're talking about is actually for me today, like functional programming, like the code is easier to maintain because I don't have like things changing everywhere. But for me at the time, because a lot of the issues that I had that I was debugging in relation to concurrency, because, well, imagine you have 2 cores, like 2 CPUs in your machine, and they are trying to change some place in memory, right? And then if you don't coordinate properly, if you don't put a lock, it can corrupt that memory. And then functional programming will say, well, we are not mutating things in memory. We are just, everything's immutable. We just transform it. And then for me, it was obvious. I was like, like all those issues I have been having, like trying to debug, trying to understand, if I was writing it with this functional style, the issue would disappear completely. And for me, I like to say, like, that's my favorite way of solving a problem. Because you can solve a problem like, putting a tape in there or like adding something to it that addresses it. But if you can remove the problem altogether, like the root of the problem altogether, that's better. And I was like, okay, this is great. And then I was like, okay, I have to learn more about functional programming. And so I started to learn more about Haskell, Scala, and eventually I found Erlang. And Erlang for me was, so the thing about Erlang was that, like, if we go back 11 years ago, all the languages that were coming up at the time, like Go, Clojure, they all had a concurrency story. Like, they're like, oh, you can do async. You have, like, Clojure had the software transactional memory. Go had the Go routines with channels. So everybody was talking about concurrency. And the thing that stood out about Erlang was that not only they solved the concurrency problem, but they solved the next problem. Because what is the next problem? Imagine that you write a software and you want to run it on your machine, and you want, if your machine has 4 or 16 cores, you want that software to be as efficiently as possible. That's the concurrency. But if a machine is not enough, for whatever reason, you need more machines, or you want to have some reliability, now you need to have like several machines working together towards that problem. And that's the distribution. And that Erlang already solved it. And Erlang solved it, today it solved it like 4 decades ago, right? At the time it was 3 decades. And I was like, this is awesome, because not only it has solved the problems that I want to solve, but for me, it solved the next problem as well, which is when I'm going to need distribution. And that was the reason for Elixir. It's really, if there was no Erlang, I don't think Elixir would exist. And then I just wanted to try different ideas on the virtual machine. And from this winter exploration of ideas, some stuck around, and that's why we have Elixir, pretty much.
Okay, thanks. And kind of a follow-up to that, like at the beginning, was that like a side project for you, or at some point you decided like that the existing software and programming languages are no good and you want a revolution and create something on your own?
So it started as a learning project, pretty much, and the whole history is on GitHub, so you can actually and the first prototype was actually really bad. Because I was like, okay, I want to learn more about Erlang and how it works, because I was like, I really want to use this technology, but I needed projects. I needed like ideas to play around, and one of the ideas was creating a programming language, especially because I don't have the computer science background. So I was like, well, might as well like learn how programming languages work while learning how the Erlang virtual machine also works, like try to get 2 birds with 1 stone. And so at the beginning I was like, okay, I'm just playing around, and then I built a prototype. It had a bunch of like flawed ideas. Like the first version of Elixir was actually object-oriented. It was just never released. It was just a prototype that I was experimenting with. And then with time, and then like this prototype failed, I actually stopped committing with the project. But I was thinking like, oh, okay, like I had those ideas, they were bad, why they were bad, how they could be better. And then I was like playing with these, you know, like just sketching things around. And then eventually I think I came up with like the abstractions that I thought, wait, you know, like I think those abstractions here, they make sense. So like I did a commit like in January, and then I was playing with it like just for fun for like 3-4 months. And then in the next winter, in December, I started committing again with something that is much closer to the Elixir that we have today. It's actually like, if you get Elixir 0.5, which is like 11 years old, it already resembles a lot the code that we have. There are like differences, of course, but the code already resembles a lot what we have today. So it was at that moment where I was like, okay, I think I figured out the abstractions that we need to have in this language and how it's going to work within the Erlang virtual machine. And at that moment, I used to work, I was co-founder of a consultancy, Platform Attack. And then I went to my co-founders and I was like, hey, can I work on this part-time? And they said yes. So at some point, this was like 2012, I think. I had like some part-time. So I was still in projects, but you know, I had like, let's say like afternoons to work on Elixir. They bought the idea, what I wanted to do with it. And then when it started working out some years later, I became full-time.
Thank you. I believe we have some questions from the chat.
Yeah, from Doch Kobakala, I think. Seems like the pool of Elixir developers reduces, which can be a red flag for companies evaluating to change their stack when they understand that hiring can be difficult. Do you have any initiatives in mind in order to increase the availability of Elixir developers?
So it says that the pool is reducing or something like that? Yeah. Citation needed, but yeah. Yeah, so usually what I say is that, and this does not apply to Elixir. Well, it's hard to say if the pool is increasing and reducing, if we're going to take it seriously. Like, usually the data that I have, it's actually very hard. Like, people ask, like, how many people are using Elixir? And I'm like, I have no clue, because, like, there is no way for me to collect this data, because there is, like, I cannot even tell you, like, based on how Elixir is installed, because there are so many ways you can install Elixir, and they're not, and I do not have this, right? But like things that we have from like events, like we're going to have like Elixir conference in Europe now in April, and it's going to be the biggest Elixir conference in Europe that we have seen so far, like by number of attendees. It's going to be, I don't know if I can give the numbers, but it's the biggest by like 20 or 30%. So, you know, if we're looking at that, it's like, well, it's the pool reducing, maybe, maybe not. So, but going to the question, I think there is a good question in there, which is, well, you know, how are you going to adopt a language and based on, or any other technology based on the pool of developers? And the thing is that, like, I talked to some companies where they're like, look, we were using like JavaScript or Ruby before, or Python, and then we were having a really hard time hiring. And then when we started doing Elixir, it was actually easier because it was a differential for us, because we were competing. Like if you're a company doing any tech stack, right, you are competing with other companies that want to hire Python engineers or JavaScript engineers or C# engineers, right? And you have to compete. So and then they said, at the moment we started doing Elixir, that became a differential, because the diagram, the Venn diagram of like Python developers who are interested in Elixir, that offer became very exciting for them, and that worked out. But we also have companies that I heard that they were like, look, we had a small team doing Elixir, and then it was working fine, but you know, like half of the team left, we could not grow the team, and we had to eventually replace. So we hear like both kinds of stories. And I think the thing is that it's very hard for us to generalize. I think a company, when they are adopting a technology, they have to consider, like, how we're going to reach the developers, right? Like how, even if it's Python, right? Like, well, if you are a Python company where you're trying to hire in San Francisco, it's going to be a very different story, a very different competition if you're trying to hire remote in Europe, right? So you have to consider all those factors, how you're going to reach out with the community, how, like even the domain that you're working on. So for example, you can get something like crypto. There are some communities that may be more open to crypto, where other communities are like, yeah, we're not interested in doing crypto stuff. So you have to consider all those things and make an informed decision, right? And not only for companies, this is also for people as well, right? Like if you're saying, hey, here I assume that everybody like chose at some point to invest in Elixir, right? But some run into it by accident, but some have to make a choice. Like, look, I'm going to invest my career in this. What are the opportunities that I have around me to work with Elixir? Like, what are the companies? So I think those are the general considerations and what you can do. How we can hire. Do we have to teach people? Is our company capable of teaching people? How we have to change for us to onboard developers? Because one of the things that has happened with Elixir, for example, is because most Elixir in general, right, is that Elixir is not the first programming language of most Elixir developers. It's not the first one. So usually people, when they started doing Elixir, they already have some experience. And the companies, for them, it's great because like, okay, we're doing Elixir, and choosing Elixir kind of it's already a filter of people with experience. So they're like, oh, this is great. Like, we're hiring Elixir developers, and they all have experience. They are more senior, so that's very positive for us. And life is so good because when we hire people, they already have years of experience in their back, right? But now you have to, one of the challenges that we have as a community is that we have to break that. If we want to continue growing, we need to be able to onboard developers, junior developers, people who are just starting programming, coming out of university, and have the mechanisms, have the materials, have the courses for them to grow. And that's something that we have been, that's something that I think 2 years ago, the community has kind of identified as a pain point. So we have companies like Dockyard, for example, that they are now like building a Dockyard Academy to onboard developers who may have like little programming experience. I like to think that our work on Livebook and having a platform where you just double click something and you have Elixir running in your browser and you can type things, get feedback, visual feedback is going to be something to help onboard that experience. So yeah, to answer the question, again, long answer, is I think it's not only about what like the Elixir team is doing. I think it's a question of like what the community as a whole is doing, but also what you as a company, as an employer, right? How are you seeing your company in the ecosystem, and how you're going to contribute to the onboarding of new developers. Just one last thing to say about this is that there's also the factor of time, right? So like 2 years ago, especially with the beginning of the pandemic, a lot of things changed. Like there was more remote work, which meant was like a good opportunity for somebody, in somewhere in the planet to get a job elsewhere, and companies, they were overhiring. So it was like everybody was having trouble to hire, right? There was a lot of competition. And then at that time, like whatever technology you chose as a company, you would struggle with hiring exactly because there was so much competition over hiring. And now 2 years later, we have a slightly different scenario. Some companies tried out the remote, now they're going back, others they're going all in. And we've heard that we have been having a bunch of layoffs in the last months. So how that's also going to change how companies hire and how people are employed, it's also a factor to consider, just like macroeconomics. And that also, I think, also plays into the answer. Well, I was not expecting to talk about macroeconomics, but sure, yeah.
Okay, I think we have like for at least one more question like that.
I think like we can keep going until pizza comes.
Okay.
If
That
José
sounds
wants
good.
to, I mean,
Yeah.
like, you can't beat pizza, so I think this will be the sign. No?
Okay, so yeah. There's a question.
So, I have a question about static typing. In particular, how is the work going?
Yeah.
And do you have any results you could share us with? For example, maybe at the moment you know that there will be nothing with static typing, or maybe
Yeah.
the other way around.
That's a very good question. To answer, we'll have to turn off the camera. No, I'm kidding. So to make sure everybody's on the same page, we started a really research and development project for bringing static types into Elixir. And as a research and development project, there are two steps. There is the research part and there's the development part. And I'm very happy to say that we are like at the last part of the research thing. Okay, so what this means, so what is this research? Basically, there is a type system. There are several types of type systems, and we are working with one which is based on set theoretic types, which I personally find very intuitive because everything is based around set operations that we learn like school or high school or something like that, right? Like it's like unions of sets, like intersections of sets. And so I find it's very intuitive, and the whole research is like, well, can set theoretic types apply to Elixir? And to answer this question, we break into two things, which is, well, what are the things that we can do with Elixir today that we can model with set theoretic types, right? So if you say, look, this function can return like an integer or a float, a number, right? That's a union between integers and integers and floats, right? So it's integer or float, that's what you get. So the work is like applying everything that you can do with Elixir, like think about case, pattern matching, guards, intersections, protocols, behaviors. We look at everything the language can do, all the data types, maps, lists, tuples, and like how can we model all those things with set theoretic types. So we did that, and when we did that, we're like, okay, this works for set theoretic types, but there are those things in the language that we don't know how to model them. And now we have to do research. We have to answer the question, like, all those things that we don't know how to do, can we figure out a way of doing it? So, and some of those were big, like, can we type all of the guards with set theoretic types? Guards are very important with Elixir, and if we can't do that, then the solution is not going to be good for us. Another one was with maps. So we did this work of like what works, what doesn't work, and then we were like, okay, these areas we have to research further and improve the theory, improve the set theoretic type theory, so we can type those Elixir constructions and data types. And we did that. And we, in this case, does not include me because it's mathematical work. So Guillaume Duboc, which is the PhD student, and his tutor, is that the correct word? The researcher, José Castanha, they are the one working on this, and they figure out those hard problems, and they are writing papers right now. So, they can publish the papers, and then it's going to go to like academic conferences where people can validate those ideas, see if they make sense. And that's why right now, like, we're writing papers, and we're going to write something that is called a position paper. It's just like a high level overview of everything that we have been doing. And this one is because I've written a little bit, and I hope we're going to have it out like relatively soon, let's say in the next 3 months. So that's where we are. And then we will finish publishing those papers. It's going to validate. Maybe people are going to find things to improve. And then we can head into development, right? So that's the stage where we are. So, and then we're going to develop, we're going to find a bunch of other challenges. Like maybe we're going to start implementing. They're like, oh my God, like it's super slow. We have to figure out ways to optimize. And maybe we won't figure out a way to optimize. And maybe the whole idea, we'll have to throw it out and research maybe something else, another type system. But that's why right now, like research, we did the research work, and now we are finishing it up, like publishing the things that we need to do, getting some theoretical validation, and then we can start with the development, which is also going to be like a long-term thing, but not committing with anything. But I think like in a year from now, maybe we are going to have like some beginnings of set theoretic types in the Elixir compiler. You as a developer are probably not going to interact with it yet, but the Elixir compiler may start to know about those things and start to reason about your code in a different way. And we'll start assessing like, how does that impact the compiler? Does it make things slower? Does it make things faster? Can it find some bugs for free, And yeah, so that's where we are in this journey, going from research into development. Yeah, thanks for asking.
Okay, there was another question.
So just by looking at your GitHub activity, we can see that you take part in a lot of projects like Core Elixir and other stuff like Ecto and so on. I myself remember putting some PR to Livebook at Sunday 11 p.m. and you responded like in 3 minutes. So my question is, when do you sleep?
Yeah, so that I'm not at the computer at 11 p.m. on a Sunday, but I do have kids, so this could have been like the short answer when I sleep is when my kids let me. That would be the most appropriate answer. But sometimes, it just happens that like they wake up and then, I lose my sleep. So I'm going to do like some phone browsing or email browsing until I can recover some sense of sleep, I guess. But yeah, I try, outside of that, I try to live a normal life. Yeah.
Thanks. There's one more.
Okay, so I wanted to ask, are there any plans for improvements of Elixir language server or any official support for any IDE? Because sometimes writing in Elixir, even with like great tools like Mix or Hex, feels a little bit like writing in Notepad when you don't have a lot of features from other languages like automatic functions renames or variables renames and stuff like that.
Yeah, so Dashbit supports Łukasz, who is one of the maintainers. Like we support Łukasz to work on it part-time. And I recommend everybody to get involved. It's an open source project. So, like get involved. There's probably already a community around this, like that is thinking about those problems. I think they recently added like the first refactoring, which was like convert from pipeline into pipeline or something like that. So some base work happened, and now maybe they are starting to do more of that, and we can start having like more refactorings, bigger renames, and so on. The other thing is that with working on Livebook, is that we started incorporating some of the language server things started to incorporate some of the language server things into Elixir itself to make life of the Elixir language server developers easier, because what they had to do is that some of the things like require you to know how Elixir parses things, so they would use private APIs. And then there was a new Elixir version, and then because it was a private API, like that would change and it would break. And so, some pieces of the code, like they have like 4 or 5 conditionals about doing things in a different way. So what happened is that when we started working on Livebook, it turns out that like Jonathan, he was implementing the feature for Livebook, which I had implemented in IEX, and Marlos, which was one of the initial people working on the tooling around the language server, he was also working at Dashbit. So he implemented that at the language server, so to be used for the language server. So we had like 3 people at the same company that implemented the same thing 3 times. And they were like, okay, it's enough. Like, there is plenty of evidence that we can start sharing some of the work. So that's when we have a module in Elixir called code.fragment. Because the hard thing about an editor, so Elixir, it's like, when we have to understand your code, like when we have to compile your code, we are always working under the assumption that your code is correct. Like, there is no syntax error. And if there is no syntax error, we're just going to say like, yo, this is bad, fix it. I won't continue until you fix it, right? The hard thing about an editor is that even if the code is incomplete, it has a syntax error, it's invalid for a compiler, it makes no sense whatsoever, the editor still needs to make sense of that and give suggestions, because the user is relying on your suggestion for them to fix what is wrong. So, so that's the hard part. So we have this module in Elixir now called code fragment, which is exactly to reason about fragments of code that is incomplete, and how we can reason about this and which information we can get about it. So we are starting to improve, but this is still like we are working at the base level, and I feel like some of the features that you mentioned, they are like from the top level, and I think like the community should like step in and help figuring out. And I think it can actually be super fun, because like working with compilers, parsers, it's like, this is the kind of work that you usually, you don't do at work, let's say, right? It's like, it's a different domain, so it can be very challenging and exciting. So I do recommend like exploring around.
Thanks. Okay, so maybe before we jump once again to Michał, I have I have one more question. Could you share some updates on what's next for the Elixir, for the upcoming versions? What's the current focus?
Oh yeah, yeah. I was writing because the next Elixir version is going to be soon in 2 months, and I was writing the changelog, and I think this is going to be our most boring release ever. There isn't really like a lot of things. It may be exciting if you have a really, really large Elixir application, like thousands of files, because some of the, I spent a lot of time in the last weeks, like I got access, somebody say, hey, the compiler is slower. Then I'm like, oh, sure, like how many files do you have? They're like 2,000. I'm like, oh, okay, this is great. And I was like, can I get access so I can play with it? So I have been playing, like, I got access to 2 really large applications, and I have been debugging them to make the compiler faster. Because when you're at this point, like when you have like 2,000 files, right, like bottlenecks, they start showing up in places you don't expect. So for example, one of the bugs that I found was that the compiler was calling like ls, you know, the list directory command from Unix, was calling that in the directory. And it turns out that if you have 2,000 files, you're going to have like 2,000 bin files. And now calling ls, it's something that everybody's going to assume is going to be fast. I'm just listing the files in this directory. Now that thing becomes slow. So you have to rethink the algorithm, and you have to rethink in a way that it's going to be fast when you have a lot of files, and it's not going to now become slower for things that only have 20 files. You don't want to make everything else pay the price. So I think that's the thing. Like, there are a lot of improvements both in OTP and in Elixir for like making the compiler faster and making like, so for example, if you do like mixed test, there is some time while we are booting everything for us to see the result of running the first test. Also making that shorter, right? Like instead of like I've seen some improvements in the work I've seen that I've done so far where it's like 30% faster. So you know, if before it would take like 4 seconds, it's going to take like 2.8 seconds for you to see like the first dot, which for me it's a very meaningful gain. So that's going to be the exciting things. There is, I think, everything else that is exciting that is happening is happening outside of the community, you know, with Livebook, with machine learning. There was a new Phoenix release now with focusing on Higgs. There's probably membrane stuff coming out. I think most of the exciting things are elsewhere.
Okay, thank you very much.
Yeah.
And I think that's going to be the last question, like, judging by the what's going on behind there. So, Michał.
Oh, Mateusz, do you want? Okay. So I wanted to ask about Elixir Nx. Does Elixir Nx have any production deployments?
I'm sorting for information that I can talk about. Okay, so the answer is yes, but I'm trying to see which one I can talk about. Did anybody see like the Christopher Granger keynote at Elixir conference in the United States? Yeah, I'm almost sure that that's public, and I'm almost sure that he talked that he's using both Nx and Explorer. And I know of another case that I am working to make it public. Yeah, so I think I know. Yeah, so the answer is yes, but you can probably count on both hands. That's where we are. The goal is to count on both hands and both feet, and then move on from there. Yeah. Baby steps.
Okay, so thank you very much.
Yeah, thanks
a lot
everybody.
for joining. Yeah, thank you.